Another inrush current limiting solution is by using a transformer. So let us interpose a transformer in between. So let me include a transformer like this. So you have the primary, you have the secondary with the dot polarities like this as shown, and let us say the primary to secondary turns ratio is 1:n. So if you have a voltage V primary, V secondary is equal to N times V primary. So that is what it would mean. So this is a transformer, and this is how it is connected, and this has very many advantages. First of all, it is not lossy. It is not a lossy element, and therefore the efficiency is not affected. Secondly, there is galvanic isolation. What it means, galvanic isolation, is that there is a physical isolation. The conductors here on the output side and the conductors on the input side are physically isolated, which means that if there are any surges here due to any part of the circuit on this side, or if there are any surges on this part of the side, they are not communicated to the other side. So therefore any surge appearing on the grid or the mains will not go and destroy the components on the load side. So that is one major advantage of galvanic isolation. Another advantage is that the primary and the secondary coils can have different turns, number of turns. As a consequence, you can have a turns ratio which will result in scaling. So let us say, for example, you have 230 volts here, and I want here a 15 volts to give to a 15 volt power supply. You can adjust the turns ratio such that it is a step down transformer. Or if this is a lower voltage AC and you would like to have a higher voltage here, it can be a step up transformer. So N is a degree of freedom that it gives to the designer to choose a proper scaling factor to make the voltages between the input and the output compatible. Whereas in the case of the one without the transformer, the output voltage is linked tightly to the input voltage amplitudes and fluctuations. Another advantage is the inrush current limiting, and that is why we propose the solution. So inrush current limiting is a natural spin-off by putting the transformer. I'll tell you how this comes about. If we draw the equivalent circuit, you will see that there are leakage inductances which will prevent the first cycle current inrush happening. One and only main disadvantage that I can say at this point in time is that the low frequency transformer is bulky, and secondly it is costly. Now these two points, bulky and costly, are the ones which I can consider as major disadvantages, more from the expense point of view. From the point of view of theoretical operation, putting a transformer is really good, one of the best. Because it is bulky and costly, we normally limit this kind of a circuit, putting a transformer, to low power circuits, low power applications where you don't need to spend too much on the transformer in terms of real estate and price. Now let us see how this transformer will solve the inrush current limiting problem. So what we shall do, we shall replace this transformer with its equivalent circuit. I will take N is equal to 1 for now. It really doesn't matter even if N is other than 1. So we will replace it by a transformer T network equivalent, where this is the mutual inductance M, this is the primary leakage, secondary leakage, or primary or secondary, so the winding resistances. Now this would be the equivalent of the transformer, and all these impedance, if I take M very large compared to all these impedances, there will be a very small amount of current, magnetizing current only, that will flow through this, and all the load current will flow through in this fashion. So all these impedances will act to limit the surge current. So that is the logic. So if we take M very large compared to L sigma P plus L sigma S, then if we say the voltage across this leakage inductance is VL, then by Faraday's law you have VL is L sigma P plus L sigma S dIn by dt. So assuming that this is very large and the current through this is very small compared to the load current, load reflected current that flows through. So the current is basically an integral relationship with respect to the voltage VL developed across the leakage inductances. So initially when you switch it on, capacitor here is not charged, it is like a short coming across here, and all the voltage will drop across the inductance, because that will give the maximum impedance at that instant of switch on. Omega is very high, omega L will be very large, and all the voltage will drop across the inductance, and gradually the current will start building up. So it is like an integral filter, and you will see the current gradually building up, and thereby inrush current limiting happens in a natural sense. So this is one of the very good byproducts or spin-offs of using a transformer in the circuit.